La 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 la.
Good morning, children. The other days we have learned how to find the roots of a quadratic equation. But in this session, we are going to learn about how to find the roots of the quadratic equation by the method of completing the square. Okay, let us start the session. To understand this method, we need to understand some basics. Let us see what are those. See here, children. A square plus 2ab plus b square is equal to a plus b the whole square, right? This is an identity also, and we say that a square plus 2ab plus b square is equal to a plus b the whole square. This a plus b the whole square is a complete square or a perfect square, right? But if we take a square plus 2ab only, this is not equal to a plus b the whole square. Means a square plus 2ab is not a complete square. When plus b square is added to this, then it becomes a plus b the whole square, which is a complete square. Okay. Similarly, look at this. A square minus 2ab plus b square is equal to a minus b the whole square. Here, a minus b the whole square is a complete square or a perfect square. But children, if we consider only a square minus 2ab, this a square minus 2ab will not be equal to a minus b the whole square. Okay? If you would like to make this a square minus 2ab be equal to a minus b the whole square, we have to add plus b square here. When we add b square, then only a square minus 2ab plus b square becomes equal to a minus b the whole square, which is a perfect square. To start with, let us take an example. 2x square minus 5x plus 3 is equal to 0. We would like to find its roots by the method of completing the square. Okay, but how we will solve and find the roots of this equation by completing the square method? Let us see. See here, the first thing, it is in the form of ax square minus bx plus c is equal to 0. Here I send this plus 3 this side, it becomes minus 3. Therefore, this side 2x square minus 5x remains, right? Then what we should do is, we would like to make the coefficient of x square as 1. So, to make the coefficient of x square equal to 1, I will divide both sides of the equation by 2. Since the coefficient of x square is 2, right? So, divide the entire equation by the coefficient of x square, that is 2. So, it is 2x square minus 5x by 2 is equal to minus 3 by 2, right? Here it is a polynomial by monomial case. Therefore, 2x square by 2 minus 5x by 2 is equal to, it is minus 3 by 2. Now you see, this 2 and 2 will get cancelled. Therefore, x square. Now the coefficient of x square became 1, right? Minus 5 by 2 x is equal to minus 3 by 2, right? Now children, very important thing is that this x square minus 5 by 2x, either it should be brought to the form of a minus b the whole square or a plus b the whole square to make it a complete square. Here, x square minus 5 by 2x is not a perfect square or not a complete square. To make it complete square, okay, what we will do, I will tell you. This should be either of a minus b the whole square form or a plus b the whole square form. Okay, here what we should do is, if here it is minus, then we should bring it to a minus b the whole square form. In case if here it is plus, we should bring it to a plus b the whole square form. Okay. See, what we should do now is compare. We should think that this x square is equal to a square, and this minus 5 by 2x is equal to minus 2ab. Okay. If we know the value of a and value of b, then it will be very much easier for us to make the complete square here. Okay. See, what we do is x square is equal to a square, right? So here a square is equal to x square, it implies a is equal to x, right? Then what is the value of b to make it a complete square? See here, 2ab term is equal to 5 by 2x. See here, this 2ab term, in place of 2ab there is 5 by 2x, right? Where there is minus, there is minus, but where there is a 5x, where there is 2ab, there is 5 by 2x. So 2ab is equal to 5 by 2x. That is, I write this in the form of 2ab. See here, 2, where there is a I put x, and where there is b I put 5 by 4, because if this 2 and 2 get cancelled, okay, 2 1s are 2 2s are, 5 by 2 remains, 5 by 2 into x is 5 by 2x. Thus 5 by 2x is equal to 2ab, where a is x and b is 5 by 4. Thus we found that a is equal to x and b is equal to 5 by 4. Now it becomes very much easier for us to convert this into a complete square of a minus b the whole square form. Okay. Now see here, x square, right, minus 2x into 5 by 4, because we have learned that 5 by 2x means it is 2 into x into 5 by 4. Thus 5 by 2x is 2 into x into 5 by 4 is equal to minus 3 by 2, right? Now it is a square minus 2ab form. If we add plus b square, then it becomes a perfect square. That is why to make it a perfect square, I add 5 by 4 the whole square this side. And I also add 5 by 4 the whole square this side. Because whatever is this side added, the same should be added this side, right? Now, you see, this 5 by 4 whole square and 5 by 4 whole square get cancelled. Again, we will get the same thing. But by putting 5 by 4 the whole square on both the side, the LHS can be a perfect or complete square. See here, now it is in the form of a square minus 2ab plus b square. Okay. Now, it is a complete square of x minus 5 by 4 the whole square. See here, now it becomes x minus 5 by 4 the whole square is equal to minus 3 by 2 plus 5 by whole square. That 5 by whole square becomes 25 by 16. The LCM of 2 and 16 is 16. So, 2 8s are 16, 16 1s are 16. Now, 8 3s are 24, 25 1s are 25. Minus 24 plus 25 is 16. Okay, upon 16. I'm sorry. Minus 24 plus 25 upon 16 is equal to 1 upon 16. So, x minus 5 by 4 the whole square is equal to 1 by 16. Here, x minus 5 by 4 the whole square is a complete square. If this square is transposed to this side, it becomes square root of 1 by 16. Okay. So, the square root of 1 by 16 is plus or minus 1 by 4, and x is equal to, this minus 5 by 4 is transposed this side, it becomes plus 5 by 4. Right? X is equal to 5 by 4 plus or minus 1 by 4. Right? It means I can take x is equal to 5 by 4 plus 1 by 4, or x is equal to 5 by 4 minus 1 by 4. So the LCM of 4 and 4 is 4. Thus it is 5 plus 1 by 4, 6 by 4 is equal to 3 by 2. Thus x is equal to 3 by 2 is one root or solution. And similarly, x is equal to 5 by 4 minus 1 by 4. The LCM of 4 and 4 is 4. So children, it is 4. 5 minus 1 by 4 and it is 4 by 4. Now it is x is equal to 1. So the value of the roots are x is equal to 3 by 2 and x is equal to 1. So the required roots are 3 by 2 comma 1. This is how we find the roots of the quadratic equation by completing the square, right? Okay. Let us start with one more example. Look at this. 2x square plus 5x plus 3 is equal to 0. Whose roots are to be found by completing the square method. Transpose this plus 3, this side becomes minus 3. And what is the coefficient of x square? It is 2. Divide the entire equation with the coefficient of x square, right? If the coefficient of x square is 3, divide the entire equation by 3. If the coefficient of x square is 5, divide the entire equation by 5. Okay? So here the coefficient of x square is 2, we divide it by 2 only. After dividing the LHS and RHS by 2, we have 2x square by 2 plus 5x by 2 is equal to minus 3 by 2, right? Now this 2 and 2 will get cancelled, therefore x square plus 5 by 2x is equal to minus 3 by 2. Now look at this expression, x square plus 5 by 2x. You should bring it to a plus b the whole square form. Means it should be equal to of the form a square plus 2ab plus b square, right? Since here there is plus sign, so this expression should be brought to a plus b the whole square form. Okay. Now what you should do is, see where there is a square, right, and there is x square here, right, and where there is 2ab, there is 5 by 2x. Thus children, x square is equal to a square implies x is equal to a or a is equal to x. Then this 5 by 2x term is 2ab term. Therefore, convert this 5 by 2x into 2ab form. See here, this is made equal to 2ab. So I write this 5 by 2x as 2 into x into 5 by 4. Okay, because 2ab. A is x. Therefore, a is x. And I don't know the value of b. Therefore, I adjust the value of b as 5 by 4. Do you know why? Why 5 by 4? Why 5 by 2 not? Because 2 ones are, 2 twos are. Right? 5 by 2 remains. 5 by 2 into x is again 5 by 2x. Though, so 5 by 2x is equal to 2 into x into 5 by 4. Now, 2, where there is x, there is a. And where there is 5 by 4, there is b. Therefore, the value of b is 5 by 4. So, children, we got the value of a is equal to x and b is equal to 5 by 4. Now, it will be easier for us to convert the LHS in the form of a plus b the whole square. Look at this. X square plus 5 by 2x is 2 into x into 5 by 4 is equal to minus 3 by 2. Now, it is not a complete square because it is in the form of a square plus 2ab. It needs plus b square to be added. That is why I add 5 by 4 the whole square this side and 5 by 4 the whole square this side. So, to make it LHS, the complete square, I add 5 by 4 the whole square this side also and 5 by 4 the whole square this side also. Again, these two will get cancelled and I will get the same thing. But by adding 5 by 4 the whole square, it becomes a complete square. See here, a square plus 2ab plus b square, right? This is equal to, a plus b the whole square, right? Where there is a, there is x. Where there is b, there is 5 by 4. Thus, a plus b the whole square. Now it became a complete square. Okay. Is equal to minus 3 by 2 plus 5 by 4 the whole square. See here, minus 3 by 2 plus 5 by 4 the whole square is 25 by 16. Therefore, it is LCM of 2 and 16 is 16. 2 8s are 16 1s are. Therefore, 8 3s are minus 24. 125s are 25 upon 16. 25 minus 24 is plus 1 upon 16. If this square is transposed to this side, it becomes plus or minus root of 1 by 16, which is equal to plus or minus 1 by 4. Look at this. So, x is equal to this plus or minus 1 by 4. If this 5 by 4 is brought this side, it becomes minus 5 by 4, right? So, LCM of 4 and 4 is 4. Now, it is x is equal to minus 5 plus or minus 1 upon 4. So, children, x can be equal to minus 5 plus 1 by 4, or x can be equal to minus 5 minus 1 by 4. Minus 5 plus 1 by 4 is minus 4 by 4 is equal to minus 1. And it is minus 5 minus 1 is minus 6 by 4 and it is equal to minus 3 by 2. So, the roots are minus 1 and minus 3 by 2, which are the real roots because they are real numbers and they are not equal, they are different. That is why the roots are called distinct roots. Okay. So, whenever if you are asked to tell the nature of the roots, you should tell whether they are real numbers or not and whether they are equal or different. Okay. This is how you should find the roots of the quadratic equation by completing the square method. Okay. Ultimately, what do we learn in this method? A given equation should be brought either to the a plus b the whole square form or a minus b the whole square form. Okay. But remember the steps to be followed here. Okay. So children, we learned how the roots are found by completing the square. Here, ax square plus bx plus c is equal to 0 forms equation is whenever given to you, the first thing what you should do is send the c term, the constant term this side. After that, whatever it remains, okay, then you look at the coefficient of x square. Divide the entire equation by coefficient of x square. Okay, when the coefficient of x square becomes 1, then you see there remain two terms. Okay, either you should convert them into a plus b the whole square form or a minus b the whole square form. If there is a minus sign in between, convert them in the form of a minus b the whole square form. If plus sign is there, then you convert them in the form of a plus b the whole square. After transposing, you will find out the roots of the equation. Okay, work out some more examples on this concept and you will become more perfect. Okay, tomorrow we will come with the next concept. Okay, thank you.